Python standard library is kind of where Python gets the term batteries included from, because there's a lot of functionality that ships with Python straight out of the box beyond just what the language allows you to build yourself. So to answer the question of what is a standard library, standard libraries are collections of built-in tools. Typically, they're going to make operations that you do over and over again, things you don't have to write custom functionality for. So in Python, think about opening files, threading, multiprocessing, web requests, all kinds of stuff is built into the Python standard library. So if you have the Python interpreter, and it is a standard distribution of Python, it's going to ship with the standard library, so you most likely have this by default. So how do you know what's in the standard library? Well, that is all put together in the Python standard library documentation. So if you're new to Python, something that's definitely worth beginning to dig into is docs.python.org. The Python community at large is typically pretty good about providing documentation, and that stands for the language of the standard library as well. So you go out to docs.python.org /2 or 3, and then library, you'll get access to all this documentation. As you can see, this is why batteries are included, because we've got all of your text processing services, so things built in like regular expressions. You've got various data types, things like arrays that can stay sorted as you do insertions, different types of collections, which I think Colin might be talking about. Is that next month? Okay. Different numeric libraries, file libraries, and then some that you'll hear oftentimes, things like the concurrent library, networking libraries. There's a ton of stuff built in here. So when you're first starting a Python project, most demos you attend are going to have you set up a virtual environment. The next thing is you're probably pip installing from a requirements.txt file or something. But before you kind of jump straight to PyPI, don't forget there's a standard library here with tons and tons of functionality straight out of the box. So one of the things related to the standard library that I wanted to mention is how the standard library is managed. So for something to get into the standard library, for instance, we've got async IO in here now, which is new as of 3.4, I think was that when that was added. For that to join the standard library, it had to go through the PEP process. So PEP stands for Python Enhancement Proposal. If you haven't heard of that, it's definitely worth checking out along with the standard library. But the PEP process is a process to document and gather feedback around changes to the Python language as well as the surrounding infrastructure. So things like packaging, distribution, the standard library, all of that goes through the PEP process. So kind of check that out.
Can you distinguish between a library and a module?
Yeah, and let me say, some languages will call it a library. In Python, you'll probably hear the term package. But modules are individual .py files. So if you have a file that is a .py file, that's a module. If you have a collection of modules, that's a package or a library.
So, for example, the regular expression RE is a module that is included in the standard library.
Correct.
Thank you.
Yep. Any other questions on that? That is a good one. So kind of to demonstrate this, just a very small amount of functionality. Yeah.
Can you zoom that in at all?
We can try. better.
Go back to the last screen.
Like that?
Yeah.
Cool. So all of these imports here are from the standard library. No pip install, nothing, just all of this is functionality provided from the Python standard library out of the box. And kind of what we have here is just a quick application that will go out to a game API and grab some information about a set of games, and we're feeding it from the CSV file. So to kind of show the libraries, there's an OS library. We're using that to get environment variables. Concurrent futures is kind of it's a helper module that wraps things like multi-threading and multi-processing to provide a simpler API, depending on what you're doing. URL lib is for HTTP interactions. CSV, JSON. Q is a data structure, so we'll look at this, but whenever you're doing threading and multi-processing, you don't want to use, maybe your default go-to might be a Python list, but because of the concurrency aspect there, you'll need a different structure. Out of the box, Python provides a queue that can handle that for you. pprint, if you're printing things like dictionaries or other data structures that are maybe a little bit more complicated than just a string, or potentially nested, pprint's a good tool to have in your back pocket. It'll kind of print that in an easier to read way. This was one that I just learned about, but just kind of Colin pointed out, it doesn't feel very Pythonic, but I was still kind of fascinated with it, so I had to put it in here, which, by the way, talking about something is some of the best way to go explore and learn about it, because there's, I don't know, I've been talking Colin and Steven's ear off this week about stuff in the standard library that blew my mind. And then Python also offers PDB, which is the Python debugger, as part of the standard library, which allows you to put breakpoints in your code, or from outside of your code if you kind of have a more GDB type debugging experience. But what this is a command line debugger out of the box that you can use to kind of inspect your code as it runs. So, all right, so let's just jump to the bottom, walk through what's going to happen real quick. So we're going to load a CSV file with this load game data. So you can just see this. We use csv.dictreader, which is kind of handy. Whenever you read a CSV file, it then takes that header row, and you can use those as keys in the dictionary when you're referencing the column. So instead of having to keep up with things from kind of an ordinal, like this column translates to this index, you've got dictionary keys for that. And then we're going to go through. From that CSV, we're going to rip out some games to send to the API. We do that. We kind of get our URL formatted and ready to go in a list comprehension. We set up some queues, and then we call our fetch results. And so this is where earlier I was talking about threading and concurrency. So here we're doing network requests, which means we'll probably have some I/O blocking, which we can kind of do more work with by using threads. Thread pull executor kind of abstracts that. And to look at what we're doing, we create a context manager. So if you're new to Python, context managers kind of make sure that resources are acquired and released in a primarily deterministic manner, and that things kind of clean up appropriately. So think about, if you open a file, you want to know it closes. If you create a bunch of threads, you want to make sure that they block and that they all exit as you need them to. So we create the thread workers. We then set up the URLs. We send those to the workers. They fetch our data. If we catch an exception, we print that and put it in a queue. And on success, we're displaying a little bit of information, and we go ahead and take that data, encode it to a Python object using our JSON module, and put that in a queue. And all of this is on the DerbyPy GitHub repo for after. We take this set of results, we pop them off the queue. We then decide that there's an ID in that previous result. We want to get results for that. We fetch it again. We're going to do a pre-print of the data structure we create after. Look at PDB for a second. And then this is what I found interesting. We can actually determine how we want to display that data, for instance, by setting up a function that dispatches on type and format that string differently based on the argument type that we provide to the function. So let's check this out. And so up here you can kind of see pretty printing kicking in and look at kind of how that's formatted, some of that structure. If we want PDB, we can look at different things, different types of objects that we have in memory. That might not be the best. So, but PDB is there to kind of let you inspect. If you've used a debugger before, it's, you know, you can inspect variables. You can rerun logic. You could write logic in here and test it. What's up?
Okay, so with a result like this, if you rerun that, can you grep it?
Could you grep the PDB or?
Yeah, you can, like you, I forget what you typed in as results, and can you take results and grep if you're looking for counter strike?
I don't know. I've never tried to grep through PDB. I don't think you can because you're in a Python interpreter, but let's find out. No, because you're in the interpreter at this point, so it's not going to allow you to do that. But what you could do is like, fine. I can't remember. Does anybody remember? Oh, that would be a problem. Because that's a queue, so we'd have to fetch a result off the queue and then check it. But you could use Python like regex or the string module functions to do that search.
Okay.
So, and then,
Somebody asked, what's grep?
Oh, it's just a way to find text within a file or something. It's just an easier way to strip out whatever information that you're trying to find from a large amount of information. Thank you.
So PDB, we won't do a whole thing on that. Maybe that's another introductory topic, but we can hit next or in and kind of see this is the line coming up for processing, and we can keep on going through here and step through the evaluation if we wanted line by line and see what's happening. Or we can hit C for continue, and that'll print out. So the code's on the DerbyPy GitHub repo. So if you go to github.com/DerbyPy, there's a project called STL that has the README and the sample code. Two more things to call out. There is a Python module of the week by Doug Hellman that goes through the standard library, kind of each module, provides documentation and extra kind of context that might not be in the actual standard library docs. And then also the mouse versus the Python has a lot of different modules covered with some good documentation and kind of additional context around them as well. So the standard library is there, it's built in, it's got a ton of functionality. Check it out, make use of it.
Can you explain that PDB a little bit better? I didn't quite get how that works.
Yeah, so
you include a library that puts it into a debugger when you run it.
Yeah, let me do. So down here, I have this PDB set trace function, And that is the equivalent, like if you're used to using Visual Studio or PyCharm or something, like you can put the breakpoint in a file. This is setting a breakpoint. In fact, in Python 3.7, there's a breakpoint function. You don't have to import PDB, you can just call it breakpoint, and it will kind of do the same. But that's how that looks, is up at the top, we import PDB, and then we can do this set trace. You can launch your Python script with PDB, and then like kind of if you're used to GDB or other command line debuggers, tell it where you want to set breakpoints. And just like the rest of it, that module has a set of documentation out there. It covers it pretty well. So this is looking at how to call that, set trace and different options. So. Cool. Any other questions? All right.